Hello students and welcome to SJ EduSphere, where we focus on getting maths to you in the most simplified way, where you gain good command over the subject and feel confident. The lecture today is purely focused to derive the entire trigonometry formula list for grade 11 and 12, which is very crucial for you to solve any kind of sums for students across all the boards. So please understand this lecture, pause wherever required, but do not focus to by heart the formulas. We are going to derive the entire formula list in a very simplified manner. Let us first take a recall of what you studied in trigonometry in your grade 10. So I say over here, we know of a basic triangle which we split over here as if this angle is theta. The side opposite to theta we call as opposite. The one next to theta is your adjacent, and this part is your hypotenuse. Whether you say Osha Chota or Soka Taho, whichever code you want to use over here, as we are going to derive the trigo formulas over here for sine, cos, tan, and rest of the entire formula list. So I am saying if you want the formula for sine theta, sine is opposite over hypotenuse. Similarly, if I want cos theta, cos is adjacent over hypotenuse, and tan theta is opposite over adjacent. Well, you also call tan theta as sine theta upon cos theta. Now, using this, I am quickly trying to recall my 10th grade formulas as cosec theta, which is actually 1 upon sine theta, is hypotenuse over opposite. Your sec theta, which is 1 upon cos theta, is hypotenuse over adjacent, and cot theta, which is 1 upon tan theta, which is also cos theta upon sine theta, is adjacent over opposite. The other trigo property which you have learnt is sine square theta plus cos square theta is 1. Now you tend to by heart the other two formulas. I say don't. This formula you know at any point of time. So I say sine square plus cos square is 1. Now divide across everything by sine square. So sine square upon sine square is 1. Cos square upon sine square is cot square theta. And 1 upon sine square, which we know is cosec square theta. Now you divided everything by sine. Cos should not feel bad. Let us divide everything by cos square. Sine square upon cos square is tan square theta. Cos square upon cos square is 1. And 1 upon cos square is sec square theta. This brings me to the three identity formulas what we need. Now, what I need for your grade 11 and 12 is something over here called as a unit circle. What is a unit circle? Well, I have a circle over here which is having radius as 1. So, suppose I take any point over here on the graph which is at a distance of 1. I am calling this point as x comma y. What does that mean? That if I drop a perpendicular over here, will this over here be at a gap of x? And this over here will leave me at a gap of y. Hence, can I call this height over here also as y? Now, I am calling this segment over here which is at an inclination of angle theta. A unit circle with an inclination of angle theta. Students, can we come here and say that what will be your sine theta? Can I say sine theta is opposite over hypotenuse? Your hypotenuse is 1. So sine theta is y upon 1, and cos theta is adjacent over hypotenuse, that is x over 1, leaving me with x, and hence we are going to write henceforth this x comma y as cos theta comma sine theta. What do we know? Do we know that in the first quadrant x and y both are positive? Had this angle been in the second quadrant, so do we know over here that in the first quadrant x is positive, y is positive? In the second quadrant x is negative, y is positive. In the third, x is negative, y is negative. And in the fourth, x is positive, y is negative. Pause. What have you found over here? That x is actually cos and y is actually sine. That means cos and sine both are positive. So all your trigo formulas are going to be positive. In the second quadrant, cos is negative, but sine is positive. So all your sine angles which you will plot beyond 90 will be positive. Beyond that, cos is negative, and hence tan, cot, and sec will be negative. Cosec, which is a sine family, will be positive. In the third quadrant, x and y both are negative, means cos and sine both are negative. So cos upon sine being negative, tan will become positive, and its family cot will also be positive. Similarly, in the fourth quadrant, cos is positive and its family sec is positive. And hence, my quadrant rule says in the first, all are positive. In the second, sine is positive. In the third, tan. And in the fourth, cos. So add sugar to coffee is one of a very common code which we can use for a quadrant rule. Now, why am I explaining you this today? Because we have studied the trigo table up to 90 degrees, that is only the first quadrant. Today, I am going to take you around 360 degrees and give you the angle for all these 360 degree values. Before that, henceforth, we will be denoting a degrees in the form of radians. So, the measurement over here is we will denote 180 degrees as pi radians. This is how now we will denote our degrees. So, let us go ahead with getting your trigo table in place for all the 360 degree values. So, I am saying the most easiest and the simplest way which we used to find, we are going to go ahead with that. So, over here I have sine, cos, tan, cot, sec, and cosec. Over here I have 0 degrees, 30, 45, 60, and 90. I will be filling up those 3 columns later. What trick did we use in our grade 10? We used to write this as 0, 1, 2, 3, and 4. Then divide everything by 4 and take the root of it. What did this bring us with? Well, this helped us derive the entire value for sine table. So, my answer over here, 0 upon 4 is 0. 1 upon 4 under root is 1 by 2. 2 upon 4 is 1 upon 2, which under root will be 1 by root 2. 60 will give you root 3 by 2, and 90 over here is 4 upon 4 is 1, the root of which is 1. Do we observe that with this method I've got all the values of sine? Well, if you know these values, students, you can derive the entire table. So do not by heart, understand how we are going ahead with that. Whatever values you've got for sine, the reverse will give you for cos. So my cos value is typically the reverse of it, which over here will become 1 root 3 by 2, 1 by root 2, 1 upon 2 and 0. Done. What is tan? Tan is sine over cos. So can I say sine over cos? 0 upon 1 is 0. 1 upon 2 divided by root 3 by 2, 2 and 2 cancel, leaving me with 1 by root 3. Same number upon same number is 1. 2 and 2 got cancelled, left with root 3, 1 upon 0. Anything upon 0, students, is not defined. Take a pause. I walked to your class today with 0 chocolates and distributing to 40 students. 0 chocolates distributed to 40 students, what will you get? 0. But on Sunday, I turn up to school with 40 chocolates, giving it to 0 non-existing people, ghosts, not defined. So anything upon 0 is not defined. What rule did we use for sine and cos? We wrote in reverse. Similarly, tan to cot, we'll write in reverse. So this will become not defined, root 3, 1, 1 upon root 3 and 0. Done? When I'm coming to sec, well, sec is 1 upon cos. So we have to take the reciprocal of it. So do I have over here, sec is 1 upon cos. When you don't see in the denominator, it is 1. So 1 upon 1. This is 2 upon root 3. This over here is root 2. This over here is 2. Pause. 0 upon 1 becomes 1 upon 0, which is again not defined. Once you get sec, for you to jump back to cosec is nothing else but the reverse. So that over here will be not defined. 2 root 2, 2 upon root 3 and 1. This is exactly what your Trigo table is. Have you observed all the values here from 0 to 90 are positive, which was exactly a first quadrant rule. Now I have to derive the other 3 angles. So understand, before I jump ahead, I am saying I have derived 180 degrees is pi radians. Okay. So if I want to find the other values over here, for which I'm writing 180, 270 and 360, what are you calling 180 as pi? So can I call this value as pi? I'm just writing it down. It's not in the power. So this is pi. Is 90 180 upon 2? Is 60 180 upon 3? Is 45 180 upon 4? Is 30 180 upon 6? And 0, well, is 0. Can I say 270 is 3 times 90? That will be 3 pi by 2. And 360 is 2 times 180, which will now be 2 pi. So I am going to express my angles in the form of radians. Done. Again, we do not by heart. We know the first quadrant table and I derive rest of the 3 values. Look at your table over here. Can I say if this value is 0, over here I have 90, this is 180, over here is 270 and round is 360. Whatever was the value for 0 is the same value for 360. So just copy your 0 column directly in 360, which is 0, 1, 0, not defined, 1 and not defined. So whatever is for 0 is the same for 360. Same as 0. Now, If I come back over here, 180. You have done your reflection chapter where your 0, if reflected along the y-axis, the value will change the sign. So whatever is for 0, same value will be for 180 but in opposite sign. So this is opposite sign of 0. So can I write this as 0 opposite sign, 1 opposite sign, 0 opposite sign, not defined, 1 opposite sign, and not defined. Exactly on the same concept, my value for 270 is well directly opposite 90. So whatever was for 90, same number comes for 270 but in opposite sign. So this is opposite sign of 90. So your 90 column is here, becomes -1, 0, not defined, 0, not defined, and -1. So this completes your entire Trigo table from 0 to 360. So pause, understand, and recall the method. Now I go further to derive the formula list which I need for Trigo. So before we try to derive the list, let us take an example which will help us begin the formula. Okay, we all know that the value of sine 90 is 1. Well, can I write 90 as 60 plus 30? Okay, few values which we already know. What is my value for sine 60? Sine 60 is root 3 by 2. What is my value for sine 30? Sine 30 is half. What is my value for cos 30? Cos 30 is root 3 by 2. And similarly, cos 60 is half. I am just writing a pattern of formula here. Then we will compare it. Okay. I am writing this value over here, just making it a little easier. I am writing this over here as 30 and 60. Now, can I try to multiply the pattern over here? That half into half plus root 3 by 2 into root 3 by 2. This gives me over here 1 by 4 plus 3 by 4, which is 1 plus 3 by 4, which is 1. What product I have used over here? Well, I have written this as sine 30 cos 60 cos 30 sine 60. I have simply written sine 90 over here as sine 30 plus 60, and I say that is sine 30 cos 60 plus cos 30 sine 60. So sine maintains a balance with one sine, one cos, one sine, one cos. If I give it a plus, it will take a plus. So hence I am expressing sine 90 as a sum of two values. Why am I doing this? Because in this formula sheet, students, we've got 90 to 180, 180 to 270. What about the missing values? Well, that comes from this formula sheet. So we are going to derive something over here called as sine a plus b and cos a plus b. So everyone, I remove this part and I go ahead with my formula derivation. So please understand, sine maintains a balance. When there is sine, it will always come along with cos. If you give sine a plus, it will give you a plus. If you give sine a minus, it will give you back a minus. But cos is different. Cos comes along only with cos. We say it's a little matlabi. Cos comes with cos and it leaves sine with sine. When you give it a plus, cos will give you a minus. And when you give it a minus, it will give you plus. So can I say over here, sine maintains the tune, sine cos is sine. Sine cos is sine. So I am saying over here, when I have sine A and B, it will be sine A cos B, cos A sine B. If I give it a plus, it will give me a plus. If I give it a minus, it will give me a minus. Similarly, I go for cos. What was my tune for cos? Cos comes with cos. So cos, sine, sine. So cos A and B will be cos A, cos B, sine A, sine B. If I give it a plus, it will give me minus. If I give it a minus, it will give me plus. Similarly, I come for my formula for tan and I say tan, well, tan is numerator upon denominator. So tan is tan 1 tan. Tan is tan 1 tan. So tan A with B will be tan A, tan B, 1 tan A, tan B. Understand? If I give it a plus, students, is tan A plus B sine A plus B upon cos A plus B? And when I say tan A minus B, is it sine A minus B upon cos A plus B? So understand the sign convention, because this will make your formula easier for you to resolve and to go ahead with the method. Now, once we know this, I am going ahead with another set of formula. So I have over here, I am just trying to resolve this a little, but fine. Now, once you know this formula list, what I'm trying to derive is, I am writing over here sine A plus B, sine A minus B. Again, sine A plus B, sine A minus B. Here I have cos A plus B, cos A minus B, cos A plus B, cos A minus B. Now, I am going to deal with these formulas where I am going to say, when I'm dealing with sine, you only try to have the color code matching with you. Now, I am saying in a very simplified way, everyone over here, when I'm dealing with two trigo values, everyone will have the number 2. When I'm dealing with two trigo values, everyone will have the number 2. Sine maintains a balance. So 1 sine, 1 cos, 1 sine, 1 cos. Now, understand, if I give it over here a plus, that means I am saying the sine A plus B formula plus sine A minus B formula. So the up formula plus the down formula, this part will get cancelled and I'm left over here with 2 sine A cos B. So when I give it a plus, sine will take the A. Similarly, when I give it a minus, above formula sine A plus B minus the below formula. So this becomes minus, this becomes plus. That leaves me over here with 2 cos A and sine B. So I am saying sine maintains a balance. 1 sine, 1 cos, 1 sine, 1 cos. When I give it a plus, sine will take the A. When I give it a minus, sine will take the B. Do not by heart. Now, coming to the cos formula. What did we say? Cos, when I give it a plus, both are cos. When I give it a minus, both are sine. So, over here, if I give it a plus, both are cos. If I give it a minus, both are sine. Le tera minus वापस. One of the term will be A, one of the term will be B. Do not by heart, observe this formula. cos A plus B above formula plus cos A minus B below formula. That means this part will get cancelled. I am left over here with 2 cos A cos B. Similarly, cos A plus B above formula minus cos A minus B below formula. That means here if I subtract, this becomes minus, this changes the sign, cancel, left with minus 2 sin A sin B. Keeping the same logic and concept in mind, I am deriving the other set of formula. I am going to write A plus B as C and A minus B as D. Means what happens over here? I am saying A plus B is C and A minus B is D. When I add them up, does it result to 2A? That means A will be C plus D by 2. When I substitute this A in any of the above formula, I will get B as C minus D by 2. So, while I replace A plus B as C and A minus B as D, on the right hand side, I will replace A as C plus D by 2 and B as C minus D by 2. So, what do I get over here? My third set of formula list, which turns out is sin C, sin D, sin C, sin D, cos C, cos D, cos C, cos D. So, what happens? Well, the balance is still the same. Everyone will have the number 2. Everyone will have the number 2. Sine will have one sine, one cos, one sine, one cos. Okay? If I give it a plus, sine will take C plus D by 2 and cos will have C minus D by 2. If I give it a minus, sine will take C minus D by 2 and cos will have C plus D by 2. Try to match the color code. If there is a plus, sine has a plus. If there is a minus, sine has a minus. In cos, if I give it a plus, both are cos. If I give it a minus, both are sine. Le tera minus वापस. So here one of the term will be C plus D by 2 and the other term is C minus D by 2. Here again one of the term is C plus D by 2 and the other term is C minus D by 2. So if you know these three formulas, we've derived this set of 4 formulas from which we've connected here. Now let us play a little more with these three formulas and make your formula sheet for half angle, double angle. I rewrite the formulas over here as sin A plus B is sin A cos B plus cos A sin B. Similarly, cos A plus B is cos A cos B minus sin A sin B. And the last one, tan A plus B is tan A plus tan B over 1 minus tan A tan B. Now, most of the students find a challenge with the half angle and double angle formulas. I am saying we are simply going to write A and B both as x. Can I say sin A plus B is sin A cos B plus cos A sin B? And hence I have sin 2x over here is 2 sin x cos x. So my formula sheet now has sin 2x is 2 sin x, cos x. Whatever is on the left hand side, the half of it comes on the right hand side. Now, can I say cos A plus B is cos A cos B minus sin A sin B? That means cos 2x is cos square x minus sin square x. So my second formula is cos 2x is cos square x minus sin square x. My third formula for tan A plus B is tan A plus tan B over 1 minus tan A tan B. And so I have tan 2x is 2 tan x over 1 minus tan square x. So that gives me over here tan 2x is 2 tan x over 1 minus tan square x. These are my three main formulas. But then there is a parallel list that when I take x, right hand side becomes x by 2. My sheer observation is whatever is on the left hand side, right hand side is half of it. And hence my way of writing the formula is I say sin box. Whatever is on the left hand side, right hand side is half of it. 2 sin box by 2 cos box by 2. Similarly, cos box is cos square box by 2 minus sin square box by 2. Here if you put 2x, here this is 2x by 2 and 2x by 2. It's exactly the same formula, students. And tan box is 2 tan box by 2 over 1 minus tan square box by 2. Clear? Let's fill up the middle part. Do I know tan is sine upon cos? Tan is sine over cos. So I'm giving the numerator to sine. That is 2 tan box by 2. And I'm giving the denominator to cos. That is 1 minus tan square box by 2. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. This was opposite over adjacent. Both of them need to have the same denominator, which over here is 1 plus tan square box by 2. That gives us the other set of formula for this case. Now, let us break this formula further. The identity which you already know in your 10th standard is sin square x plus cos square x is 1. Can I say, look very carefully, can I write cos square as 1 minus sin square box by 2 and you still had a sin square box by 2? That means will I have the formula 1 minus 2 sin square box by 2? I repeat, I have written cos square as 1 minus sin square. So 1 minus sin square with 1 more minus sin square gave me 1 minus 2 sin square box by 2. Now, you replace the cos. Sin should not feel bad. Can I say sin square will be 1 minus cos square? So will I have over here cos square box by 2 in place of sin square? I have 1 minus cos square box by 2. On opening this, will this be cos square box by 2 minus 1 plus cos square box by 2? That leaves me over here with 2 cos square box by 2 minus 1. So that derives my formula for my half angle, double angle. Now, all these formulas over here are limiting my answer for sine box. All the formulas over here limit it for cos box. Okay. Now, look carefully. Can I play a little further and say, if I transfer this minus 1 over here, will I have 1 plus cos box? If this minus 1 comes over here, I have 2 cos square box by 2. Pause. Do not by heart. My rule is, when I give cos a plus, it comes itself. Cos is matlabi. Remember? Now, if I transfer this over here, if I transfer the 2 sine square over here and bring the cos over here, will I have 1 minus cos box is 2 sine square box by 2. So when you give cos a plus, it comes itself. When you give cos a minus, it becomes sine. Clear? Now you dealt with this in cos. Sine should not feel bad. So can I write over here, everyone? If I say 1 plus sine box, is sine box actually 2 sine box by 2, cos box by 2? Can I write this one as sine square plus cos square, everyone? So is this a square plus 2ab plus b square? That is simply a plus b the whole square. So hence I say over here, coming back to sine box, my formula for 1 plus sine box, I repeat, when you give sine a plus, it will give you a plus. So that is cos box by 2 plus sine box by 2 the whole square. And had you given here a minus, this would have been a minus. So a square minus 2ab plus b square results into a minus. So that brings me the formula for 1 plus sine and 1 minus sine. So I am again saying, do not by heart, understand and resolve your answers. The last leg which I would want you to know, did we realize that as per my quadrant rule, I am saying here all are positive, sine, tan and cos. That means if I take any angle over here, all will be positive. This is rising by theta. But if I decline it further by theta, this angle here will become minus theta. And do you observe that when I enter the fourth quadrant, the cos value is only positive, rest all will be negative. I repeat, when I went up, it was theta, all are positive. When I go down, it is minus theta. So negative angle, only cos will give you the positive answer. And hence I say sine of minus theta in the fourth quadrant is negative. Cos of minus theta in the fourth quadrant will be positive. If you know this, you can entirely define for tan, cot, sec and cosec. In my simple language, I say, who eats up the minus sign? Cos eats up the minus sign. So if cos eats up the minus sign, students, sec also will eat up the minus sign. Clear? Now, since we know half angle, double angle, let us quickly derive for triple angle formula. What is your triple angle formula over here? So I have sine 3x, cos 3x and tan 3x. Now, a very simple way to remember this. First comes sine, then comes cos. First comes 34, then comes 43. Both will have a minus. Sine will have only sine. Cos will have only cos. 4 ka power 3. I repeat, first comes sine, then comes cos. First comes 34, then comes 43 numerically. Sine will have only sine, cos will have only cos. Both will have minus. 4 ka power 3. For tan, can I say tan is actually sine upon cos? Sine is negative, cos is negative. In any of the tan formulas, we always have a 1 over here. Keep that in mind. And so I say tan is 31 upon 13. 31 upon 13, 3 ka power 1, 1 ka power 3, 1 power less. I repeat, 31 upon 13, 3 ka power 1, 1 ka power 3 and 1 power less. This summarizes my Trigo formula sheet. The last leg which I want you to know is your quadrant rule. When I talk about the quadrant rule, I am again saying add sugar to coffee. If I tell you to give me any value, I will express it in the form of 90. So sine n pi by 2 plus minus theta. You have to ask yourself two questions. Question 1, how many times 90? How many times 90? If your answer is even times 90, if n is even, sine will remain sine. And if n is odd, sine will become complementary cos. Similarly, the next question what you ask is original angle which quadrant? This angle lies in which quadrant? First, second, third or fourth? That will decide your answer. What do I mean by this? One example to wrap it up, I am asking you, give me the value of sine 210. Can I write 210 over here as 180 plus 30? What is pi by 2? Pi by 2 is 90. What is 180? How many times 90? 2 times 90. Even times 90, sine will remain sine. But 210 is in the third quadrant. Your 210 lies here. That is why the answer of sine is negative. We know the value for sine 30 is half. So this will become minus half. Before you ask me, could we have written 210 as 270 minus 60? Fine. Sine 210, if I write it over here as sine 270 minus 60, first question, how many times 90? 3 times 90. Sine will become cos. Original angle 210, again still in the third quadrant, the sign for which is negative. And we know the value for cos 60 is half. And hence, using this quadrant rule, whether for sine becoming complementary or cos or tan or cot or any angle, you can derive any formula list for your Trigo sheet. So if you understand this entire lecture, if you watch these formula sheets properly, write it down with the correct sign convention, always keep it in front of you when you solve the sum, and I'm very sure you will never go wrong with your sums. So understand, know the properties. If you get this concept well, share it with your friends and do let me know in the comment section if this video was actually helpful for you. Thank you so much and happy learning.